Why do buildings stand, and why do some fail? Every structure you see, buildings, bridges, towers, survives because engineers understand stress and strain.
If you don't understand these two concepts, structural design will never make sense. Welcome to Kusita CENG Solutions. I'm engineer Kusa Gilebo, and in this lesson, we'll break down stress and strain in the simplest and most practical way.
By the end of this lesson, you will clearly understand what stress is, what strain is, their formulas, their physical meaning, and why they matter in real structures. Imagine you place a heavy load on a column. The load is trying to compress the material. Stress is simply the internal resistance offered by a material against an external load. Stress is the force per unit area. The unit of stress is Pascal, Newton per square meter, but in practice we use megapascal, and if the same load acts on a large area, stress becomes low, and on a small area, stress becomes high. This is why sharp objects penetrate easily. In structural engineering, we mainly deal with 1. Tensile stress as a result of pulling force, 2. Compressive stress as a result of pushing force, and 3. Shear stress as a result of sliding force. Every structural member, beams, columns, slabs, experiences one or more of these stresses. When stress acts on a material, something happens. The material deforms, strain measures this deformation. Strain is the change in length divided by the original length. Strain has no unit, it is dimensionless. Stress tells us how much force is acting. Strain tells us how much deformation occurred. In most construction materials like steel, stress is proportional to strain with any elastic limit. This relationship allows engineers to predict deformation, design safe structures, prevent cracking or collapse. When engineers design, for columns they check compressive stress, for beams they check bending stress, and for steel bars they check tensile stress. If stress exceeds material capacity, failure occurs. That's why stress and strain are the foundation of structural design.
In the next lesson, we'll discuss stress-strain curve and material behavior. If you found this lesson helpful, like the video, subscribe to the channel, share it with engineering students. This is Kusita CENG Solutions, engineering made simple and practical.